To write the equation of the transformation, we need to then still keep the x's separate from the y. So we have to know what the changes in y are and the changes in x. So I'm going to do the y's first because y's are easier. So my changes in y look like this. It's directly what is written here. I get a vertical shift up. So I'm going to take my old y and I'm going to shift it up plus 2. It compresses by 1/2, so I'm going to put it all in brackets. So the next step is going to be times by 1/2. And to do it last, I need to put this outside the brackets now. It's going to go up 3. So this is my overall transformation. Now I can get rid of the brackets and combine like terms if I like. Now I'm not going to bother doing that, but this is my transformation and this is my function notation. This is essentially my function notation. So my function notation is going to look like this. Y is equal to 1/2 f of something plus 2 plus 3. If you want to combine those shifts as looks like it's going to be plus 4, we can do that. Okay, and I'll just rewrite it here. Y equals 1/2 f of x plus 1/2 times 2 plus 3 is going to be plus 4. So we can just leave it like that if we like. Either one is perfectly fine. And that describes all the vertical transformations. What about horizontal? Well, horizontal is exactly backwards. So what I see here, what actually happened is exact opposite of what I'm going to see in my notation. So then what actually happened is this. Expanded by 2, so I'm going to take all my x's and I'm going to times it by 2. Is going to shift to the right, so plus 3, and then I'm going to take all of that and flip it. And so there's my transformation. Now this is my description, but my notation is going to be exact opposite of that. So I need to reverse this. Well, I have a process of reversing, which is solving or undoing. So I end up undoing that minus. I'm going to undo the plus, and I'm going to undo the times 2 with the divide 2. And there it is. There is my transformation in reverse, which then represents my notation. So I could rewrite this then as negative x minus 3 all over 2. And in factored form, if you want to write this in factored form, I can factor out the negative 1/2, and I end up with x plus 6. Okay. Actually, sorry, this is already in factored form, isn't it? This is going to be, I just factoring out the negative, so it's going to be plus 3. So this is a horizontal compression horizontal expansion by 2, a horizontal flip, and a shift to the, in this case I've shown this as a shift to the left, but because we switch around some of these things by putting in factored form, it shows up as shift to the left here, but really ends up being a shift to the right because of that horizontal flip. So there it is. I'm going to stick with this one here because I'm comfortable with this one. I don't really need to have it in factored form, but if you like the factored form, that's what it looks like in factored form. And the notation is always the reverse of the description. So that's what ends up showing up in there. I want to write this in the square root form, so f of x, my new f of x, so y is equal to, it's going to be everything on the outside is going to be 1/2 square root plus 2 plus 3, and on the inside it's going to be 16. I'm just going to write this as 16 here. 16 minus something squared, and that something squared is my transformation. So negative x minus 3 all divided by 2.